I'm going to turn it over to you, Paul.
All right, thank you very much. So as we've said, this is Makerspace Series Part 1, because we fully expect there's going to be a lot more that we need to cover after today. Hopefully your feedback is going to give us some ideas for some future webinars, future topics. So your questions and your feedback are going to be extremely important for us today. All right, let's get into what we're going to be doing. So we'll have our introductions. We'll go through our objectives. We'll review Snap Circuits Junior, review Snapino, and then our last portion is going to be a discussion with professionals in the electronics field. Chancey Fleet, Antonio Guimaares, and of course Ken, who we'll introduce in a moment. We'll wrap up. This is an hour and a half of CEU credits today. Please place your questions in the chat. We absolutely want to know what you want to talk about and what kind of questions you have. That's going to really help us for the future. So our first thing, this is the Snap Circuits Junior kit. You can see the picture of here. You can use it to build more than 100 different things, all sorts of ideas. I played with this thing once and really had a good time just making all kinds of fun little things. You'll see one of those today. This is a quota-eligible product, $129 for students 8 years old and up. It's labeled in Braille. There's instructions in Braille and large print. Let's take a look at Snapino. It's quota-eligible. It's $75. Gives you an introduction to the Arduino hardware software coding environment. You can use it with Snap Circuits Junior. And our first presenter is Ken Perry, programmer with APH. He'll be part of the panel, and along with that, Chancey Fleet from the New York Public Library, Assistive Technology Coordinator. And Antonio Guimaares, who is just a graduate, actually just graduated. We'll talk to him about that a little bit later on during the panel discussion. Here are our objectives. Good, thank you. It's finally wanting to cooperate. Okay, so the participant will learn what a primary electrical circuit is and what is meant by a series circuit using the accessible Snap Circuits Intro Kit. The participant will learn how to make a blinking light circuit and how adding the two Snap Circuits kits can create an accessible talking and blinking light circuit. And finally, the participant's going to identify 3 careers in electronics pursued by persons who are blind and visually impaired. And actually, we're hoping it's going to be a lot more than 3. So 3 is just the minimum. We'll hopefully hear about a whole lot more than that today. And with that, it is time to turn this over to Ken.
All right, I'm going to make a slight adjustment to the objectives because originally we had said we were going to do series, which is what that first objective says. I'm also going to do series and parallel just to give you an idea of why we even mention it.
Okay, Paul, stop sharing, please.
Sorry. Again, my name is Ken Perry. I work for American Printing House. I develop hardware, software. I am 100% blind, and this is the kind of stuff I really love to do. So I'm just going to jump off. You guys can see here, my hands are floating around. Those who can see, I will also describe this. I have a small thing in my hand. It's about maybe 2 inches by 1.5 inches.
Okay, hang on. I'm going to make you pull it into focus.
Pull sorry.
Forward with your hand. That's okay.
Right.
Keep going forward. Keep going forward. Keep going forward. Thank you. And it's focused.
Gotta love these cameras that self-focus. So this is what they call a breadboard, and it's a tiny breadboard. And the reason I'm even showing it today is to explain why the Snap Circuits are really so cool for blind and visually impaired users. I actually built this. It's just a little sounding board. So if I push this, let's see, if I push this switch here, can you hear that over this? If not, let me move my earphones in it. So that right there is just a little button. It's got a battery. It's got a little piezo buzzer. And I could put one of these. This is a little bitty tiny motor. Can you see that on this camera? It's just a little tiny motor.
Yep.
And then I could put a little light in there. But as you see, these are really tiny. And if you're new to this, as a blind or low vision person, it's really hard to find these little squares, and there are all kinds of ways to do it by, using little pins like I'm doing right now. I'm using the end of the light to find these holes, but as you see, it's difficult. So what I like about
that way up, there you go.
So what I like about the snap circuits is I don't have to do this, and I don't have to do the small parts like I'm showing here. I mean, these things are really tiny. We're talking smaller than your pinky. The battery is as big as your thumb, and so they're really small. So what we're going to show today is a better way of doing this to learn it, and then we can come back to a harder way once you've learned how to do the electronics. So this right here is the Snap Circuits Junior Kit box. I'm going to open it up. I'm going to spin it around because they put the lid on backwards, it looks like. As you can see, there's some stuff here. I also have I have to pull this box out and get I moved it so I can get it easily. This is the Braille that comes with it. As you can see, it's a large book. I think you can see the end of it.
You are, yeah, very edge. We can't see the left side of what you
I was trying to lean it so you could see how thick it is.
Yep, we can see it.
Okay, so it's several, maybe 100 pages, I think 82 to be exact. And then it also has a low vision booklet. I won't go into those. And then it has the original picture booklet for the instructions. This kit works a lot like Legos. The instructions that come with it by default are graphical. So I think you probably see some if I open it up for those who can see. But it shows you each step of the way to build it. And what we've done is made step-by-step instructions to go with it. This is the kit. For those who can see, for those who can't, I'll describe it. It's got a baseboard, which is 10 by, well, I guess it's 10 by 7. So yeah, 7, because it goes to G. So we go 10 across the top, 7 down the front. Now, what's nice about this is kids can also learn spatial orientation and grid navigation while they're learning to build these things, because the way we place pieces are by doing letters. So like B2 to C2 or something like that is in the instructions. Now I will talk about the parts first, and then I'm going to have Leanne show the first instructions so we can talk about series. And so what we've got here, can you see all the parts, Leanne?
Yeah, you want to push the box upward and to your right.
There you go. How's that?
A little bit further. A little bit further if you can. I know you're running into the camera leg.
That's okay. Is that good?
That's good.
Okay. So what we've got is 3, they call them IC chips. These have multiple parts in it. Now, these are all sound chips, so they make different kinds of music, different kinds of alarms. And for the instructions, they'll tell you when to use them and what to do with them. I will mention, I just noticed that these are not defined on how they actually work in our current documentation. I'm going to try to fix that. So right now you pretty much would have to build the current projects the way they say, and if you wanted to go out and do a search, figure out what U1, U2, and U3, how these pins are laid out and what all they do. So this is something we're going to have to fix. But these are these music chips. This is a motor. We've got a motor.
That's the one thing. We can't see the motor.
Let me carry it over here.
There you go.
This is a motor, and it has a little fan blade that you can put on top so that you could, when you spin it, it'll blow, up or down depending on which way you're spinning it. We have switches. We have buttons. This is a photo resistor, which for light and dark. This is a lamp. Doing this all by feel, but they're all Braille labeled, and the kit is all Braille labeled so that you know where to put stuff back. These are LED. Let's see what we got. This is a sound board, sound chip. It's a whistle chip.
So how did you know it was a sound chip?
So there's a WC whistle chip, and it also has a square hole. So I know basically I have every snap circuit kit there is, so that's why when I'm touching things, most of them have distinct feel, but we do have braille labels. Like I said, this says WC. Now the speaker, as you can see, it looks like a speaker. When I say it looks like a speaker, it looks like an old jukebox, I guess. So you can tell that's a speaker just by feeling it. The speaker does not have braille on it because it really doesn't need it. Oh well, I'll leave it out right now.
Counterclockwise if you needed it.
Oh, did I? I had it wrong. These are wires. These are actually snap wires. So they have snaps on both ends. And the reason they call them snap circuits, by the way, if you've never seen one of these kits, is they actually have snaps. Like if you have jeans on and they have snaps, these are the same thing. And that's how they connect the electricity. So these are snap wires. They're hard wires. So we would count the bumps on each one. So this is a 1, 2, 3, 4, 5 snap wire, and that goes across the board if you need it, and need it to go across 5 of the grids. And then they have a 7. They have different sizes, so you can make different size stuff. Now, have I lost everybody? Because that's pretty much going through all the stuff. Because we got LED lights. An LED light has to be a certain way in a circuit, while this lamp can go either way, and our instructions tell which way, positive or negative, the pieces need to go. The braille on the device is always on, or on the, let's say the LED, is always on the positive side of the part. So let's look at a
So
LED.
you're going to say the braille is always on the positive side of
right.
the device.
It's in the instructions, and once I find an LED in this box, well, maybe it doesn't have, maybe this one only has, so the LEDs will be in the Snapino. Haha, I'm terrible. It has a lamp here, but it doesn't have any LEDs that I've found yet. So I've just went through all of them. It looks like the LEDs in the Snapino, so that's what I get for not making sure this had LEDs. So this has a lamp, and the lamp does not, this is good because this is for, this is also a resistor here. A resistor is just a load that you could put on your circuit. So this lamp here can go either way, and it's a good thing for a starting person that's working on snap circuits. So that is pretty much all there is to the Snap Circuits Junior, which is kind of amazing that you can make 100 different things out of this kit. That's just with what they tell you could do. There's other things, if a student's really into it, they can make all kinds of things. I had a 3-year-old and a 5-year-old that played with this, and they came up with some pretty interesting things, and they didn't even know what they were doing with electronics. They just stuck stuff together till it worked. And that's one thing that's nice about the Snap Circuits. There's not much you can do to blow them up, although there's warnings in the instructions that, don't do things this way, that way. They've pretty much made these parts so that even if you mess things up, you're not going to blow things up right away. So now what I want to do is talk about series and parallel, and that's something that you're going to learn right off in electronics. So I'm not going to go really deep into it. Leanne has a couple links that she'll send out at the end of this 30 minutes that it has a basic description of series and parallel, and then it has a more in-depth series and parallel discussion, and that goes all the way up to physics. So it gets to the point where you can calculate how many electrons will flow through a circuit, and that's with this basic circuit that I'm going to show you. You can do anything from as simple as this is a circuit all the way up to what kind of physics you can get out of it, which is pretty impressive. They actually use this in college. They use it in PhD level, all the way down to grade school, elementary. So this might look like a toy, but it's a toy that has quite a bit of power because it's actually using real electronic stuff. All right, so we're going to start out and just build something. So I want to, let's see, what am I doing? Okay, so we're going to start out with the first instructions. Leon, if you want to put those up for people, they can see what our instructions look like. And then I'm going to see if I can
So the instructions were given in the handout. If you did not receive the reminder email, I'm going to type the handout link again. Inside that handout link are actually 2 links, and he is talking about the first link.
Yeah.
The second link is his resources.
Okay, so this right here, the first piece I'm going to put down, well, I'm not going to put it down because this is not the first instruction. I should follow the instructions, so let's do that. I'm going to build this first one, and then as I've told everybody that when we're working on this, I'm going to do it kind of like a cooking show so we can speed it up to see the parallel circuit already built, and then we'll talk about
So
both
if you
of
will
them.
push the box forward on the table and move your grid forward.
This forward? Oh, yeah.
Yep.
Yeah, I'm
We
going to get
can't
that.
see what you're doing.
Okay, so if you have the list, it says parts right here.
That's good. Up a little further will be better.
Right there?
Yep.
All right, because I'm going to hold this in front of me so I know what I'm doing. So it says parts needed, and it's got all a list of parts, but I'm not going to read them off because, well, I guess I could.
I can read them off as you're going if you want.
Well, I'm going to do that for the layers. So I'm not going to read the parts because each part will have an instruction on where to put it. So I'm just going to go down to the layers, and it says first layer, and it says place L1 lamp, and it says B2, B4. So this is where, like I said, this is something to teach kids how to use a grid system, and it says B2, B4. We can see if I can do this without messing it up. So I put the lamp down on the B2, B4, and it says place motor C2, C2, E4, I think, or no, C2, E2, and that will be right here. So right now I've kind of made a upside down L for anybody who's blind, and it said positive on C2. So I got to make sure I turn this around where the braille is on C2. If I would have put that in the wrong way, all it would have done was made the motor turn backwards. So like I said, it's pretty forgiving.
So I know you know this set really well. How do you know, or what strategy did you use to get to the correct grid to place that down?
So I'm going to do that right now for those watching. Because this one's a harder one to place. It wants me to put the battery at B4. I think it said B4. Hold on, let me make sure. Oh, D4,
slide
F4?
your grid to the right. There
so
we go.
it says put it on D4, F4. So I'll go A, B, C, D. That means I just did ABCs down the left side, and then I'll go 4 over. 1, 2, 3, 4. That's D4, and it said go down to F4. So F4 would be down below, so D, E, F. So we're going to place it right here, which it said place the positive one on D4, and that's what I did. So that is where the batteries go. And then it said place whoops.
2 snap
F2, F3, right? 2 snap F2, F3. So I'm going to get that out. And these are 2 snaps. Like I said, these are little short wires. In some kits, they have ones that are just 1. So this is, let's see, I'll do this again. A, B, C, D, E, F. 1.
You're off our screen. You got to push forward.
2. So what? Push forward?
Push forward. Yep, there you go.
A, B, C, D, E, F. 1, 2, 3. It said 2 and 3, right? And so we'll put that right there. Now, it looks like I'm complete. Looks like I have the first layer complete, right? I think that's the last instruction in the first layer. Let's move on. Okay, and then it says place 2 snap.
So now
B2,
you're moving to the second
layer. So now I'm still counting A, B, and then it says 2, so 1, 2. But now I'll put it on top because there's a piece underneath it. Just like building Legos. Well, if I can snap something today. All right. That's that. So we got 1 down. And where did I put the other? Oh, I already used the other. I'm getting some more parts out. Sometimes it's easier to take all the parts out before you get to building it. So you could always read the parts list and pull them out. And then it says place 2 snap E2, F2, and I'll go A, B, C, D, E. And it says the E2 to F2. So there's 2. Got that. And now, and it says place switch. So we'll get the switch out. And that goes up here. Now, interesting enough, this is something I might want to fix in the future. You always want to connect the battery last. At least this is connecting the battery last at this juncture down on the negative. I usually like to do the switch last. So when you're reading these instructions, that might be something you want to do. Now it's asking for F3, what? F3, F4. So that goes right there. Now, unfortunately, where are my batteries? I'm going to have to steal the batteries from this one over here.
You have 2 batteries on your right-hand side on the table.
See, it's great to have sighted help. All right. I am terrible at losing batteries and everything. So I'm going to put these in now. There's the battery. Now the springs go, of course, negative. Everybody. And we'll put the negative here, flat into the battery. And the switch was on. So this is a series circuit. And the reason it's called a series circuit is because there's one path for the electricity to go. As you can see, the
push the grid forward again. It slid forward. There you go.
Okay. As you can see, there is one path from the battery plus side. The current will flow around in this circuit counterclockwise because that's the only way it can go. Round through the lamp. I'm going to remove this fan. Through the lamp, through the motor, back around through the negative side of the battery. So it's a real simple circular circuit. When it's a one-pass circuit, that means it's a series circuit. Now the current flows from positive to negative, and the electrons flow from negative to positive. So they go the opposite direction as current. You can get into all kinds of math stuff on where the voltage is, what the voltage is at different points, how many electrons flow through a certain point. There's a whole bunch of stuff you can do mathematically. The links that Leanne is going to put up go into that really in depth if it's something you want for a higher level course. So now the interesting thing about a series circuit is the voltage or the load, since it has to go through each item, it actually drops the voltage as it goes through the load. So that means when I turn it on, let's see, I'm going to turn it on. You might notice that the light is dim and the fan is turning kind of slow. So if I take the fan off, the light will get brighter. Now, for those who can
Actually,
see,
the light turned off.
the light turned off. Shouldn't have turned off. Is it going?
It's still
Well,
off.
okay. So this is a good thing. You notice it's moving and the light's really dim. What's the problem is probably if I turned off the lights in here, you'd be able to see it, but it's really dim. The reason is I'm running this on a low amount of batteries for this type of circuit. Now, what you're going to see is when I get to the parallel circuits, that's not going to be an issue because right now, all the voltage has to go through the light and the fan, and it's really working hard to get this fan to move. But the light is not getting enough voltage to actually.
When you put your finger on top of the thing where the fan is, the light comes on bright.
There you go, because I'm stopping the motor from moving. So it's not being forced to move. It's just using the motor like a wire. So that's correct. That's a good thing to see. So in a series circuit, the load has to go through, or the voltage has to go through both or all of the load devices on the circuit. So now what we want to do is go to the next instructions. So that's a series circuit. The series circuit says you have to go through everything in a row. Oh, it's 12:30 already?
Yep.
Well, then we're going to have a little bit over on this one, but
That's okay.
We'll catch up. We'll catch up. I'm grabbing the right one, I hope.
Time flies when you're having fun, Ken.
Well, you know, I guess I didn't realize the the intro does take time. So
while you're doing that, the person says, is it because the fan motor is spinning even faster since the blade isn't on it and taking power away from the light?
yes, and but when I stop the light, it just becomes a wire, or stop the fan, it just becomes a wire. Thus, the light gets all the voltage, whereas the motor gets very little. It just goes through. So this
push forward.
Yep, push forward.
Forward, a little bit further.
Forward.
There you go.
Now, if you look at this, you know, basically it looks like the same kind of circuit because we have a motor, we have a battery, set of batteries, same set of batteries, 2 batteries. We have the same lamp, but as you notice, let's say I take my finger and I go out of the positive side, goes through the switch just like the other one, and then I get to a turn where we can go to the lamp or we can go on to the motor. So that means electricity has 2 paths, okay? And so if it has 2 paths, it's going to get the same amount of voltage to both devices, and then it comes back. So let's see what kind of difference this makes. The battery should be charged just about the same, and it's the same 2 devices. So will it be the same? Let's find out. I'm going to turn it on. So do we have a light?
You have a light and you have a spinning fan.
And it's spinning pretty fast too. Now, it won't even change if I took the fan blades off the other one, it actually gives more power to the light. But if I take the fan blades off this or knock it off, it didn't change the light any because they're getting the same amount of voltage to both. Now, one thing is a parallel circuit will probably eat more power, but it's always going to give more power to each device. So that's the main difference between series and parallel. You have 2 paths or more paths for a parallel circuit. In a series circuit, you always have 1 path. So I guess are we going to do questions at the end of each 30 minutes? Or are we going to do questions?
At the moment, I haven't seen any questions come in except the one I just asked you. So I think you can keep going. Questions.
So finally, just so you know, and I'm sure the questions are out there. I didn't know, but just so you know, the way your house is wired is parallels, and the reason for that is if you had, and I've got the fan running, even though you can't see that running. I've got the fan running, but in your house, if you were to unplug your refrigerator or if you were to unplug your fan or if you were to unplug anything, you don't want your lights to go out. So in parallel, you can actually, disconnect things as long as you don't break the whole,
just a hair so we can see.
As long as you don't break the whole circuit, you can disconnect stuff and then it continues to work. I think the light should be on, correct?
It is.
Yeah, and then I can reconnect. So it's just like plugging stuff in and unplugging things, although I think I lost a piece. So, well, that's okay. It's pretty bad when you want to show something and it breaks. I'm putting it together. So anyways, you can take parts apart. I lost the piece. I think it flipped out across here. Oh, there it is. Yeah, okay. So I'm going to put this back together real quick. I didn't mean to destroy it this much. Okay, so now I can plug the fan back in, and it should start working again if I don't put it in the wrong place. So this is why your house would run on parallel circuits. Now I'll just leave it up to you guys to decide if your Christmas lights at home are series or parallel, because there are 2 different kinds in the world, and I think it's interesting to know that a lot of the old ones are series and a lot of the new ones are parallel, and now you'll know which one are which, because if you pull the light bulb on a series, it'll stop it from working, and if you pull the light bulb on a parallel, well, only that one light won't work. So there you go. So that's series and parallel, and if there's no questions, I think we can continue on. Yes? All right, now what we're going to talk about, let me get this one out of the way, is the Snapino kit. Once I pick it up off the floor. All right, Leanne, is this one right side up?
It is, but you got to slide it to the right
I'm getting it
and
there.
forward, and you have 2 fans in front of it that you're going to push.
Good. All right. So this is I don't know what's on this picture box. I don't know if it's even worth looking at, but this is a Snapino kit. There are no Braille inserts. Well, there's a Braille insert telling you where to get the Braille. The Braille is online. You can download it to use it on a Braille display or to print it. The instructions are all online. What we've done is moved the new Snapino kit to all online, and that makes it a lower cost unit. Also, we'll be making 2 more kits, and we wanted to get everything online and drop the price of everything. And so that's why we've went to an online platform. But the Braille is available. You can use it on your note takers. So I'm going to spin this around and take a look at what's in this kit. This kit has, again, a baseboard.
Push a little more forward.
Yeah, sorry.
There you go. That's good. Perfect.
This has a baseboard, but if you'll notice, the baseboard is half the size of the other. I don't think it's exactly half the size because I think it's 7 across and 1, 2, 3, 4, 5 down. So that'd be E. So 7 by E, I guess you could call it. So the instructions are smaller. Now you could build anything that's in this kit on one of the larger boards if you need to, which I have done, and I'll show you an example of that. But this is a smaller board. This is the main part of the Arduino kit, and it's about, for those people who can't see watching, it's about 3 by 2, and this is the Arduino board. So inside is an actual Arduino board. For those who don't know what that is, it's a maker's, pretty much as a small computer. It has several digital inputs and outputs on the sides. They've made snaps for some of them. So this is digital I/O 9, 10, 11, but there are much more. So there's 0 through 8 on this line that you can use for pins. But normally in snap circuits, we use the snaps, but it's really up to what you're doing. You can actually put shields on this. I've actually interfaced this with a Braille display. If you purchase the shield. Now, I didn't give a link to that, Leanne, so I need to do that later.
Okay, we'll give it out after the presentation.
Yeah, so this is a plus, this is a minus, and this is A0. So we got D9, 10, and 11. All those are on snaps. And then we have a whole bunch up and down through here. I do believe I gave you the document for the Snapino, and on there's a whole description of what the power, where the power is and everything on this. But this is the main part of the Snapino kit. With this and other kits, you can make almost anything. So like we're going to be coming out with a rover kit in the future. You'll be able to make a full roving robot that that can talk, can do all kinds of things, sense distance. All right, so I'm going to put this back in here for right now. We got wires, and when I said you have more, when I said you have more digital inputs and outputs, here's a pin snap. So it's got a snap on one side. I don't know if you can see that. Snap on one side and a pin on the other, and you can put that pin in these slots, and I'll show how that works on one of my kits that I've built here in a second. You have LEDs. These are the LEDs I was talking about earlier. They look like little lights, and they have a bias, so that means you have to put them in correctly. The plus sides are the ones with the Braille. And then we have a light sensing transistor. It looks like an LED, that's this one, but it actually is a on-off switch that is turned on and off by light. So the brighter the light, the more it's on, and the dimmer the light, the less it's on. So it's a light transistor. You have a programming cord. You hook that to the computer, and you have a 9-volt battery pack. Now that's something you'll need a screwdriver for. And once you take it apart, you can it's just one screw. You put a 9-volt in there, and that's how you power the unit. Now, you don't need to put a battery in that right away because you can actually power the unit from the computer using the USB.
Which type of computers can you use?
You can do Mac, you can do Chrome, you can do anything the Arduino can. So there are actually ways to do it even using your iPhone, but I don't know how accessible those are. In fact, we might I don't know that they are that accessible. So normally I use Windows, or I use Mac or Chrome. And Chrome is getting better by the day because they're making a web programming, but I didn't put those in the resources because they're still kind of difficult to use. Most blind and low vision people use the Arduino IDE, even though it's not the most accessible. APH has actually added accessibility in so that some of the tables for managing your boards and stuff work. But the nice thing is there's nothing extra you have to download with the Arduino IDE. That's in those references. You just download the IDE, run it, and it has the Arduino Uno, which is what's in this. It's the Arduino Uno. You just set it, plug it in, and it should show up. You got to set the COM port, but in the COM port, they'll say Arduino Uno when you have it plugged in. So it'll help you set up. And if anybody has any trouble, I'm available in emails. I would love to show people how to do it, and maybe in the future maker things that we want to do, we might hold a whole class on how to program and manipulate this. So with that, that's everything that's in this kit. I'm going to now show you some of the cool things you can do with it. And let's move this out of the way. If you guys could see my office, it looks like Geppetto's toy store right now because I have stuff all over. Okay.
Do you know if the Braille instructions are available as a separate item?
The Braille instructions are downloadable free. So they are available at any time. I mean, you can go get them right now, in fact, at tech.aph.org/Snapino. So they are available for you at any time. Even if you haven't purchased this, you can download it. So what I'm going to do, and I'm going to unplug this right now because I want to show you from the beginning. All right, so what I've built here is probably the most simple thing that you can build with the Snapino kit. It has, I'm getting my battery. It has the Snapino on the left, the Snapino here, and it has an LED hooked to the D9 with the positive side toward the Arduino, and it has the negative side hooked to a 3-snap, and then they're both tied into this, I call it a negative bar, because as you see, this is the negative. It goes to this 4-snap wire, and then it goes to the LED and back into the Arduino unit. Now, what I've done, if you look in the source code that is in that handout, right, Leanne, that got sent out, the handout?
It did, and I put a link inside the chat as well.
Okay, so this, don't need this here. Is that far enough up?
It's good.
Okay, so this is a basic, if you look in that source code, you'll see where it says D9 high and D9 low, and that's it turning on and off the light. So if I plug this in right now, I've coded this on the computer, and then I've unplugged it so it has a full memory and everything. You could teach it to do just about anything, and when I say anything, I mean just about anything. So I'm going to plug this in, and then I'll show you how to make this more accessible. Well, one of the things, these old USB things, you kind of have to spin them around, so when you're trying to plug this in, it won't let you plug it in the wrong way, but I don't ever remember which is the right way. Okay, so it should now blink every 2 seconds. Is it blinking?
Yes.
As a blind person, I have no idea.
Yes,
I just
it
know
is blinking.
Right. So I just know I coded it to blink, but I don't know if it's blinking, right? So if you look in that code, the source code, I've done some extra stuff that would make it more accessible. Now, the most easy way to make this accessible is to remove the LED and replace it with a horn chip. Now, here's the problem.
What are you replacing it with?
I'll tell you a sec. So here's the problem with the horn chip.
Horn.
Yeah, it's called a horn chip. It's W1, I think. You hear it beeping, of course. It's on. Now it's off. Now it's on. So I replaced the LED with a sounding chip, or the sounding piezo. It's a piezo buzzer. And now I can remove it and put the LED back on. So I could just replace the LED with something that makes sound. as I did in the source code, I can add an extra output. And now that extra output is sounding the horn while the light's blinking on and off, correct?
It is.
Now here's the problem. This horn chip, or this horn piezo buzzer, does not come in either the Junior or the Snapino. That is why I gave the link to the Linkro parts. You can actually buy this separate. So since this doesn't come with it, I just wanted to show you that that could replace an LED, but you can do something totally different. This speaker comes in the Snap Circuit Junior and the Snapino. So now I have, and I'm going to put my things down here. When it blinks, when it's high, it does the tone, and when it's low, it does this deep tone. So what I've done is I've made a on-off tone so that when the light blinks, I can tell it's on and off. And that's just with an added speaker, okay? Makes sense? Now, if I wanted to make a really accessible blinking light circuit, what I'd normally do is add speech to my system, right? So I'm going to snap this on here. I'm going to put this. Remember I said there was extra digital outputs?
We can't see the this, so you'll have to push it forward again.
Is it all the way?
This is. Keep going.
I was going to show you.
Oh, now we can see the red thing with the wire.
So you see where I'm at. I'm going to count with this pin 0, 1, 2, 3. So I've put that in the third hole. Well, it's really the fourth because it starts at 0. And then I've added a ground, and I'm going to put the ground over here. Let's see. Now let's see if we can hear this. Nope, doesn't seem to. Hold on a sec. The problem is this has no amplification, okay? So once it starts talking, lights.
Did you have to add a code to be able to add the speaker or
No.
the horn?
So if you notice, if you look at the code, I have already added everything I need for this in the code. I can just switch the parts and it picks up that I have another part and it starts talking with it. There it goes. I'll see if we can hear it.
We heard on, off.
Did you guys hear it?
We heard on, off.
Yeah. So when the light comes on, it says on, and when the light goes off, it says off. It's that simple. So you could just add, if you look at the code, it's just one line of code that says speak this word, and it speaks it while the light comes on. So it's not extra coding, as you know, I don't have to write the speech software. I just download the library, which is the Talkie library. And if you look up at the top, it includes a talkie.h. And the Talkie library can be downloaded with the Arduino IDE if you go into the library dialog. So it's all there with the Arduino IDE. Now, what's my time doing? Don't want to run over.
You got 10 minutes.
Good, perfect. So now what I could do, again, this is an extra part that you can buy, and I'll show you. So this right here, if you know, well, let me get the, right here, right?
Yep, good spot.
Looks like a triangle. It has a little earphone jack. So what I'm going to do is I'm going to use my handy dandy speaker that I have, a battery powered speaker out of my desk. You can also plug an earphone into this, but I wanted this to be audible. So I'm going to plug this in, and then I'm going to change the snaps from the speaker that you guys just barely heard, I'm sure. And I'm going to plug these snaps into this.
We can't see where you're plugging.
I'm gonna move it over
good.
where you can see it. I just need to be able to reach it. And
yep.
Unfortunately, I'm short-armed. Okay. So if you look, what I've done is I put the triangle on my little my speaker, and I've snapped the two snaps that used to be in the speaker now in this. Now you can definitely hear it say off, on. So now when the light's on, it says on, lights off, it says off. And so you have a fully accessible blinking light. And now you could do this with just about any circuit you work on, you could make it talk. So with that in mind, let me unsnap this and I'll show you how crazy you can get.
Before you do that, the
Yes.
bar speaker that you had in your hand, did that come with a kit? Did you buy that separately?
No, it's just one of many powered speakers I have.
How did you attach the
so here, let me show you.
triangle to the speaker?
Let me show you. Where I just put it down. I'm gonna have to hire a sighted person.
Well,
Sorry.
social distancing, you're alone in the office. We know how this is right now.
I know, but you know, I just put it down. I think I left the speaker over here, didn't I? Yeah, okay. So, can you see it?
Push a little further forward. I know, I gotta stretch those arms.
No.
A little further.
I'd rather have to stretch than everybody see my gut hanging over the desk. How's that? Okay.
That's good.
So this is the triangle piece that you can purchase at that parts site that I gave you. But if you unplug it, right here is just a regular 1/8 or 3.5 millimeter jack on the speaker. So this speaker actually has a jack. I could have used a wire to get to it, but all I really did was took the triangle and I plugged it in. So there you go. So that's how it's on there. Make sense?
Thank you. Yes.
Yeah. Okay. So I'm going to leave the triangle on there because I'm going to use it here in a second. And then I'm going to, so now I'm going to show you something much more advanced. Chancey, I think, saw a little of this, but so this is where you can go with the Snapino. This is the Snapino, just like you saw. And over here to the right is the Perkins size keyboard. We have 3 keys, space. Now here's something
So wait
interesting.
a minute. For the people who cannot see, he did not grab keys off a Perkins keyboard.
No, they're lined up like a Perkins. So you have them spaced. So on the left, I have 3 keys. On the right, I have 3 keys. And down at my thumb, I have another button. When I say keys, they're actually the Snap Circuits buttons. There's only one button that comes with the Snapino kit, but I have purchased extras, and I just wanted to show people what kind of stuff you could do.
That's okay. I just wanted people who couldn't see. No, you did not pull keys off of it.
No.
Perkins.
So, but it looks kind of like shaped in the same setting as
Yes, it
this.
does.
Perkins. So it also has this speaker over here, and I'm going to plug this in. But what's interesting about the Snapino is it has enough memory. It has enough memory to actually make a computer. The Braille and Speak. If for those who know what the Braille and Speak are, if you don't, it's kind of fun to search for. The Braille and Speak was one of the original PDAs. It was a note taker for blind people, and it just said power on, circuit ready, and I'm going to plug this in so you guys can hear it. But now I'm going to take this. I'm going to take this and put it into the speaker because I have an amp on this, so it's more loud. If you can hear this, I'm going to. Did you hear that? So I have a power amp on this,
Yep,
but
we can hear it.
I think it's better if I plug it into the speaker. So I'm going to do that. All right. So here we go. Snap and snap. Now, if I type, and I'm going to reach up here. Well, maybe I got the snaps backwards. Terrible. When the demos go wrong. So, well.
Definitely can hear it.
Sorry. This take us just a second and I'll fix it. This usually is better. Okay, that's a negative. And this is, oh, I see what's going on. All right, input, output.
Well, while you're doing that, I will say I can remember using a Braille and Speak with my students.
Did you?
Oh, yes, I did.
Was that, I missed mine. Well, this is peachy.
Well, let's just say you
Okay,
put a
well
lot of effort
let's say
into it. You
this is
know
a
it'll work.
yeah, this is an easy way to the whole point of this was I had a blind group. Wow, that was beautiful. I had a group of
Yep.
blind people on our Orbit reader list when we originally. Well, that's not going to work.
Well, that is the part and the fun of electronics is this is a safe troubleshooting and getting the bugs out.
I'm sorry. So I guess my point is that we had students on our Orbit reader list, and they asked me as a blind person how they could develop their own Braille device or how they could develop their own Braille display, speaking device. And so what I did was I created one that they could create from it. And now, right now, this one only talks, but in the future, here we go. Okay. So I can even fix things when I'm fighting with stuff. So it's got letters. I can hit space, which sounds really funny. Well, I guess my pins are out. That's what's happened. A lot of things have gotten pulled while I moved. So, but you heard it reading letters. I can type with it. I can save a file with it. And in the future, I hope to have the entire Braille and Speak stuff working on this one board so people can just sit and play with it. And it's a very short bit of code. If people are interested, I can dig up my partial code right now and send it out. But this was just something to show you the kind of things you could do with it. And once you learn the Arduino system, do I have a minute or two? What do I have?
Yeah, you got 2 minutes.
Good, perfect. Once you learn with Snapino, you can do just about anything. And I'll show you a mess, but this is a robot. I do have a link to Parallax in those references I sent you. This is an Arduino board underneath it. Can you see that? This is the power. So it's the same board that's in the Snapino. So once you learn to program with it, this little robot becomes fully accessible. I built this with no instructions. What I want to do is write, I want to write accessible instructions so people who've never built stuff like this can do it. But I'm a geek and I could do it. But I just wanted to show something you can do with Arduino once you learn to use it. And another thing, here is what the Arduino board looks like outside of the Snapino right here. So this is an Arduino board outside. And these are the extra pins that would be inside that plastic case. So that's what the Snapino or the Arduino looks like outside of the case. So, all right, well, I think I've spent my time.
I would say you have, and we want to be able to welcome our panelists for our last half hour. Majority of the questions that we did find, we were able to answer. So I'll let them think about if they have any questions about those, but I would really like, Paul, are you ready to introduce our panelists?
Yes, we're ready to get the panel started. So we introduced everyone briefly, and we'll let them say more about who they are and what they do. Chancey, Antonio, and of course Ken's going to be part of this panel as well. A lot of questions we could ask. We want to know what you're doing, what sort of careers you could be involved in, but let's start with education. So Antonio, since you have just completed your education, tell us about that. What your education is, what you hope to do with it, and also some other things that you could do if you wanted to.
Thank you. I'm Antonio, and I have a master's in interactive telecommunications from New York University. My first class was a class called physical computing, which was all about Arduino. At some point here, I'd like to give that out as a resource, the website for that course. I continued from that physical computing class through programming, through design concepts and wearables. Wearables was heavy into Arduino again. And Arduino is sort of, I would almost describe it as a platform of sorts. I mean, it's not just the Uno that you see in the Snapino and that I'm holding up here with a whole bunch of other stuff attached to it. But there are dozens of different boards that you can run, and some can keep time and some can do amazing things with Wi-Fi. And so at NYU, I learned to use Arduino, and along with the coding that makes it work, and of course, with design concepts that go along with trying to make something. So it's that's my background for the last 2 years. So I will let the next person.
Sure, let's
ask
let
the question.
Chancey then, I guess, talk about her education next then.
Hi, my name is Chancey Fleet. I am currently the Assistive Technology Coordinator at the and I am a co-founder of the Blind Arduino project and of our for tactile graphics and 3D objects at NYPL. My background is not in STEM at all. In fact, when I was in school, I was discouraged from pursuing advanced STEM subjects, and I didn't think that I really had an aptitude in those subjects. And looking back on it, I think it's because of the way that I was taught. I was often given textbooks with very few graphics when it came to math and sciences, and I was often given lab partners that would complete a lot of the steps in my labs. And so I gravitated to psychology. I did my undergrad in those subjects at William and Mary, and then studies at the School for Professional Studies, City University of New York. And it's not until I came into my personal position, my current position as an assistive technology coordinator, that I started exploring STEM as an adult and implications for accessible STEM in the community. Instead, I've been educated by blind mentors and sighted allies, and I've kind of learned by doing. And at this point, education at the New York Public Library, we're able to offer education in tactile graphic design, physical computing with Arduino, and allied subjects like soldering and understanding tactile schematics.
And we know that Chancey has been having sound problems every once in a while. She's been trying really hard to work on it, but everybody has their own internet issues. Chancey, did you finish?
Yes.
Okay, thank you.
Was I relatively clear this time?
Yeah,
the
there
most
was
part.
a couple spaces.
Yeah, we caught most of it. So
Okay.
what about your education, Ken?
So do I even have a video on? I don't even know.
No, we see your
Okay.
your desktop.
Well, maybe I'll figure out a way to turn that on here in a bit. So my name's Ken Perry, as everybody knows. I have a bachelor's in software engineering. I have a associate's level degree through the Air Force for electronics. And I have 30 years of gadgetry, which is pretty much I put together everything I know and I build things. I currently am working on a probe for American Printing House that will be, because of Arduino, it's easier to make. So it's going to be a new chemistry probe that will allow you to see, look at liquids and see how dark they are. That way a person doing a science experiment can actually stick it in a acid or something without having to put their fingers in it, which makes it all the better. But I pretty much work on software, hardware, and anything geeky. So
You talked a little bit to us last week about being discouraged a little bit from the field also and still wanting to get into it. Can you talk a little bit more about that?
So like Chancey said, I mean, when I lost my sight in the military, they gave me pretty much three choices. They said, well, you can be you can go back to school for law or psychology. You could do masseuse. They had the weirdest things. And at that time, I didn't know about the Smith Kettlewell. If I did, my path might have went really different, which I'm not sure would have been a good thing. But they were doing electronics. I mean, as far back as forever. Blind people have done electronics. If you look up Ralph Teeter, he was a blind guy that made the cruise controls in your car. And if they would have told me about that, about Smith Kettlewell and their electronics programs and stuff, I probably would have stuck with electronics. But because the military didn't know much, and I knew when I lost my sight in the military, I went back home, and as any young guy might do, sat down and learned my computer by rehab and then by video games. Don't ever scare your kids away from video games if they're low vision or blind. But I played video games a lot. And when I got into college, I knew I could use a computer. So I told them, well, why can't I go for software engineering? Because it's something I did when I was a excited kid, you know, early on with like the Atari 800s and stuff. And they were like, well, you know, you're blind and I'm not sure you can do very well. And this was in the early 90s. So I just told them I could do it. And I ended up doing all my calculus blind, no braille, no, just audio out. So you don't always have to go with what people tell you. They definitely discourage me from doing anything technical, which is just my blood and bones. My dad was a electronics engineer, and I couldn't see myself doing anything else. So
now, as I keep asking questions, please remember you can go ahead and ask your questions in the chat as well, so we can get some of yours in. Antonio, since you just talked about graduating, tell us what you'd like to do, but also, if you could, some other things that you might be able to do with the degree that you have.
Sure. I am looking for work in user experience design, and basically that entails coming up with interfaces and the way things look, the way things feel, the way things are positioned on an app screen or on a website, or a calculator, a keyboard, a piano, hardware and software, both alike. As far as the Arduino, and I think that something like this is really serves a person well who wants to go into museum exhibits, for instance. A lot of museum exhibits are done with either Arduino or some other type of computer, microcomputer. You can prototype with this your idea, and you know, build with your team whatever it is that's gonna be the actual thing. But one thing that comes to mind, and that I wouldn't mind doing actually either, is museum exhibits. And there are companies out there working with this. Wearables are something that you can work with Arduino as well.
Right, thank you. So, Chancey, you talked a little bit about how what you're doing got you into the field a little bit. Can you expand upon that a little bit, and also talk about, if you were to change careers or modify yours a little bit, what other things you might be able to do with your new skills?
So I started my program at the New York Public Library when I was actually working as an assistive technology specialist in vocational rehabilitation, and I found that field a little bit constraining. And so I started volunteering at the New York Public Library to do free technology coaching with a group of other activists with disabilities. And I was able to come on full time in 2014, and also have 2 other former volunteers hired. And so we started out really focusing on basic technology education, helping people understand how to use their iPhones and Macs and PCs and tablets and things like that. And we still do that. That's still kind of the meat and potatoes of what we do. We do about 150 hours of one-on-one coaching every month, even now during the pandemic. But I started to notice that in myself and in my friends and in the community, there seemed to be a lot of people who had graphics, working with physical computing and electronics, working with 3D printing, and working with coding. And often when we go into mixed spaces, or supposedly in a standstill, we're helped with every step. Sometimes we're told that certain things aren't accessible, and that someone should just do them for us. And so that we're discouraged from following that career. And so we started to build out a program of events where Non-visual techniques are well respected and well understood. And I would say that that's about 1/3 of my work right now. So we have the Dimensions Lab for tactile graphics and 3D objects, where we teach people how to use code to design 3D objects. We use hand coding SVG and parametric design to teach people to use mathematics to design to work with sighted apps. Tactile design side by side with us. If you'd like to see an example of our work, you can head right over to tactileschematics.com. Again, tactileschematics.com. Our ally at NYU ITP, Lauren Race, made a fleet of schematics, circuit diagrams, tactile circuit diagrams that accompany the NYU course on physical computing. And we've also been developing curricula around using Arduino non-visually. So you can Google Blind Arduino Project to find out more about that. And we have also just kicked off our first blind soldering weekend intensive, where we taught people non-visual techniques for soldering. And I bet Ken can put in the chat some links to the Smith-Kettlewell technical file where you can learn more about that. And so rather than transitioning into a different career, for myself, since I am first and foremost a tech educator, I don't have deep knowledge in any one of these subjects, but I have surface knowledge in a lot of them, enough to help people along on their path. Rather than changing my career, transitioning my career, my position evolves at the library in response to what patrons say that they want and need. If I were to work with maker culture, I might work in another library at a maker space, teaching children and adults about how to turn their ideas into creative expression that involves design, coding, and physical computing. There are a lot of positions like that in schools, libraries, nonprofit, and cultural organizations.
All right, thank you. Now, I have one last question I want to ask everybody, but do we have any questions for the panel in the chat?
We have a couple. One is I have a 15-year-old who loves cell phone technology. Can you give guidance on how to get him a career in that field?
Oh, that might be a Ken question. I mean,
So,
that's
you know, the
that
real
would be computer hardware engineering, right?
yeah, it would also depend. Can you hear me?
Yes.
Yes.
Okay. It would also depend on what you want to do. There are internships with Google. There are internships with Apple. You might want to check into that. But also, you might want to look into things like Humanware, or even some of the other companies. Like I think Blazy still has a. I don't know who's doing it now though. The B2G. Those are phone systems. It's neat to be able to get your foot in the door and understand it. But at your age, I'd almost be looking at an internship with Google or Apple. Those and don't shy away from it, because if you have low vision or blind, they actually look for that kind of thing for accessibility. So if you do a search for Google or Apple accessibility jobs or internships, I think you might find them. If not, maybe we can get in touch and I can help you find somebody that would help you out. But one of the things you really need to do is get down and dirty with Android. Android's one of those free open operating systems. You can get old junky phones and you can go in and start manipulating. In fact, you can almost start your own business making accessible stuff for Android. I know Apple is the favorite in the United States, but 84% of the phones in the world are Android, and there are all kinds of companies around the world looking for accessibility for Android and Chrome. So it's, you know, those are the kind of things you need to look at, is just do a lot of research into accessibility. And if you don't want to work in accessibility, then what you're going to have to really do is dig down in the operating system and get good with it. And like I said, it's open source. You can download it and you can learn it that way.
This is Antonio. Wanted to address that question, and with a very non-technical response. I think it's really important for a blind or visually impaired child to have hands-on experience with these things, whether it's Arduino or programming or robots, whatever they're interested in. And to that end, it's really important to have blind role models who can show them how to work these things or where the resources are, and so they can see that it is possible, and not only that it's possible, but that they can do it and they are doing it. You know, how do you get an internship with Google? You start at step one.
All right, very good. Thank you. Any other questions, Leanne?
We have another one about math standards and science standards and how they may fit, snap circuits and this equipment may fit into the math and science standards.
Yes. So I think, did we send out that PDF with the Blink, Arduino Blink? Leanne?
The links, anything you gave me went
Okay.
out.
So there's a PDF that went out that says, I think it's Arduino Blink. And the interesting thing is down, if you search down, it has the next standard, I can't even say it. Next generation science standards listed there from 3rd to 6th, 6th to 12, and it mentions how you can use it in those standards. But I will tell you this: with snap circuits, I wouldn't search for snap circuits in general, although you will find syllabuses. There's all kinds of syllabuses for the snap circuits, Snapino. But if you search for Arduino and where they fit the Common Core, or well, I think Common Core is no longer, I don't know. But if you search for the standards you want and the Arduino set, Arduino or electronic kits, you will find all kinds of information on it. But where they fit, everything, it doesn't even have to be math. Everything from instruction, learning instructions, learning to follow directions, learning to give directions. There's all kinds of places where it fits in the new standards. Modeling systems, for instance, in mathematics, there's a lot of stuff. If you watch those 2 videos I sent, the second one's called Hard video for series in parallel, you will instantly find stuff where it'll fit. Everything from algebra, learning to do variables, learning to change units, that's higher up in math. So there's a lot of stuff out there.
Any other questions come in?
Not at the moment.
All right. So
Chancey, hold on. Chancey, you did give one other website besides the tactile schematics. Can you tell me what that one is again?
Oh, didn't you say the Arduino blog and also the Smith Kettlewell, right? I think.
Yes, yeah. I think she was talking about, that's what I wanted, the blog, and the other one, what was the other one?
So just do a Google search for the blind Arduino blog and it will pop right up. And then if you go to the Smith Kettlewell technical file, that has tons of background reading on blind soldering techniques.
Okay.
I think it actually might be in my reference sheet. If it's not, awesome. I don't know why.
I put the blind Arduino blog in. I didn't know about the Kettlewell, and that was the one I didn't catch.
It's Smith-Kettlewell.
And it's Antonio. I promised to give the address to the NYU ITP's physical computing website, and that's itp.nyu.edu/physcomp. PHYSCOM, like Mary P.
Do you think, Antonio, can you put Lauren's blog post up?
Yeah, I want to say I was one of the test people for Lauren, and I want to say her schematics were, I would say, groundbreaking, and I can't wait till tactile displays become more prevalent in the world, because I'm able to make my own schematics now, and it's pretty impressive. So
I have one last question, and I'm going to throw it out there to anybody who wants to take it. So can you just tell us about some of the non-visual techniques you've used to make yourself successful in the field?
Let me start, because I was actually thinking about that a lot, thinking about novices, seeing how everything unfolds. And I know when you're a teacher of visually impaired students, you're trying to learn the electronics and digital concepts and coding concepts, and also think about non-visual techniques. And that can be a lot. That can be intimidating. So the first thing that I would suggest is that you definitely reach out to blind and visually impaired mentors. The internet, the web is great for that, or maybe you can find someone in your local community, because there's no need for you to reinvent the wheel. I think labeling is everything. When you get a kit that's not fully Braille labeled to begin with, taking the time to identify things using a visual interpreter or a reader, and getting Braille labels on everything and starting to notice how things feel super important. I think if you are in a workspace and you're trying to keep track of a project non-visually, everything needs to have its place. Sometimes we use little mats that have segmented boxes for components. Sometimes we use compartments. Whatever you use though, make sure that your workspace is tidy, and when you're done with the component goes right back from whence it came. If you're trying to keep track of positive and negative connections to wires, putting a knot in the positive wire helps you distinguish them, because obviously we don't use colors to distinguish across wires. And then maybe Antonio can add a couple of things, but I would just say labeling and organization and the judicious use of visual interpreters to understand things that you can't experience directly visually, and taking notes on that interpretation so you don't have to ask the same question a number of times. Those are all super helpful, but I bet Antonio has more to say about this.
Yeah, I am holding up again this Arduino with a breadboard on it, and the reason why is that one of the things I use to move around these two things is the end of the wire itself. You know, you pick up the wire and you hold it by close to the end, and you can brush it against the sides of the hose, either the pin hose in the Arduino or the points on the breadboard, and you can count how many spaces over you're going with the piece of the wire as your cane. And of course, if it's something that you can test if it works, you test afterwards when you place your wire there, test it, the project is working.
Ken, do you have anything you want to add?
I am turning 50 soon, and I want to tell everybody, no matter your age, no matter how young you are, no matter how old you are, we all get stubborn sometimes and don't want people to help. But I had my mom and dad at 42 help label my first robot kit, and it's okay to, I know Chancey mentioned getting, you know, somebody to read and watch, but it's okay to get the help, because as a sighted person, even some of this stuff, sighted people can't always see that well either. They have to ask for just as much help as we do in a lot of cases. When I developed this probe, I developed the concept, I developed the design, but I work with engineers and I work with other people. So you got to learn to communicate with whoever is about, and you need to learn to teach them to communicate with you, because not everybody communicates the same. And so it's really important to learn to talk to just about anybody and get them to help, if that makes any sense, when you need it. Sometimes you don't, but when you need it, don't be stubborn, because all it's going to do is make it harder for you and take longer for you to learn.
One practical thing I would add to that, it's on a different subject, but if you're working with wires, when you're working with wires, yes, not the positive, so you know what it is, but also use the colors that are standard for the sighted electronics person, because you're going to be working with them at some point. And as much as they can look at your work and say, okay, this is a ground, or this is a positive wire, because I know the color, that goes far away too.
That also works in the coding arena. You know, for electronics and coding, it's really important to stay with the standard of wiring, standard of spacing, standard of returns, because a sighted person looks at code totally different than a blind person. And, you know, our code turns out pretty nasty. It doesn't hurt to use tools to align your code. It doesn't hurt to use tools to mark your cables. I've used different shape crimp tools. So like I'll use round for positive, so I can crimp a bunch of the ones that I'm going to use in positive, and then square would be the ones I'm going to use in negative. It really depends on, you know, what tools you have, but the more tools you have, the better it is. Get a bunch of tools in your box. And I don't mean tools physically. I mean tools the way you think, the way you compartmentalize stuff.
And it sounds like the value of teamwork is extremely important here, even though we didn't use that word. It really does come down sometimes to that, just having people around you that you can trust and being a good teammate and having people that you know that can assist you without really taking over and doing. Right?
There's not many engineers that work in the dark. I mean, there's not many engineers that work by themselves. You won't get very far if you're doing that.
Have any of you utilized applications such as TapTapC to determine colors of wires?
Yeah, that's really hard.
I feel like TapTapC isn't the most reliable because it'll give you a capsule description, and there's multiple things on the table. It might focus on the wrong thing. It's not 100% reliable. It's computer vision supplemented by micro web workers. So I think a service like Ira or Be My Eyes, where you're talking to a human being, can be more accurate because you can kind of interrogate the original answer and get additional details. But there too, you have to be very careful how you say things and make sure that you're pointing both the camera and the agent's focus accurately so that you can get the most accurate possible information. And it's very, once you get some information, make sure that you knot the wire, you do whatever, you write things down, you take notes, because you don't want to be accessing that same information via an interpreter more than once. I'll give you a slightly unrelated example. I like to do origami, and all the origami videos online, for the most part, are completely silent. There's just music and you see someone's hands. And it takes me about 40 minutes sometimes to go through with an interpreter and get all the steps and accurately complete a model. So at each completed step, when I've got it verified that I've done the step right, I write down what I did because I don't want to be making that call again.
Yeah, and another quick way to do that for wires is if you buy the wires color code, when you buy the wires red, black, and you cut and make your own, you'll know what they are, and as Chancey said, keep them in the spot they belong. So you could make a whole bunch of them if you knew what color they were when you ordered them.
So I have another quick question. Ken, you mentioned other kits. Any idea of what those might be to be available?
I can tell you what's coming because I mean they're coming as quickly as we can get them. The Rover kit will be accessible soon. The next one that we'll have is called the Snap Brick Structure. And what that is an interface between snap circuits and Legos. So you could actually make a Lego house with lights and fans and doors that open by themselves, because you could put a Snapino in the middle of it and you could have a little haunted Lego house, or you could have, rockets that make noise or trucks that move. Those are the two that are coming. From that point, we may take a break on the snap circuits because after you get that amount of kits, you'll be able to label your own. And I'm hoping to create a community site where people can put their own stuff. I personally have a electronics blog, but since I haven't blogged there in a while, I'm not going to really give it out. But in the future, I will be adding more to that. I currently have a couple radios and stuff up there that people built with snap circuits. But I think in the long run, I want to make that into a community site where people can build their own things with snap circuits or other kits, because we do want to make an accessible Arduino kit. And what I mean by that is if you go out and get an Arduino kit right now, it comes with LEDs and it comes with piezo buzzers, and that's about it. I mean, there are other things like transistors and things, but what I mean by accessibility wise, the speakers aren't all that good. So what I want to do is build an audio / accessible tool where you use other things than LEDs, other things than LCDs. So I hope to make a kit like that in the next year or so.
Well, we have run out of time, so I really want to thank Chancey and Antonio and Ken for a fabulous session all about electronics and that moving forward for our students. So I definitely want to thank you. This has been a wonderful session.
Thank you.
Thanks.